Welcome to the lesson on linear equations, writing the equation, the graph of a line on a Cartesian plane. We're going to talk about slope, y-intercepts, things like that. This is in Algebra 1, Saxon Algebra 1, 3rd edition, lesson 75. Plus I might cover a few extra things. So, if we want to graph a line, if we have a formula for a line, y equals something, and we want to put it on a Cartesian plane, we need to understand a few things about that. First of all, our graph must always be in this format, y equals mx plus b. You might find some equation sometimes that would be 3x plus 2y equals 6. And the first step is to arrange this equation into this format, y equals mx plus b. So to do that, here we're going to move the x to the right side. It's 3x, and we get 2y equals negative 3x plus 6. Divide everything by 2. And we get y equals negative 3 over 2x plus 3. First step, make sure your linear equation is in this format, y equals mx plus b. Now, this m, the coefficient of x, here it's negative 3 over 2. Here it's 1 over 2. It's possible that it could be any number. This m, coefficient of x, is the slope of the line. That's the angle, the slope of our line on the Cartesian plane. And this b is the y-intercept. That's where this line crosses over the y-axis. So, let's talk a little bit about slope, how to find slope, and then I'm explaining this so you know, not so it's not going to be used very much. I don't think you'll use it very much later in the lesson, but suppose I have 2 points, and I'm going to put the one point here, and another point here. So I have 2 points, if I could draw a line between them. The coordinates of this point are negative 5, 2. And the coordinates of this point are negative 2, negative 4. Oh no, positive 4. Negative 2, 4. So, to find that slope, we'll find the difference of the y's over the difference of the x's. So, take 4, and I'm going to go this one first, 4 minus 2 over negative 2 minus negative 5. 4 minus 2 is 2 over negative 2 minus negative 5 becomes 3, 2/3. So that is how you can break down, if you're ever given the coordinates, that's how you can break the coordinates down to find the slope. It's a slope of 2/3. But there's a much easier method of discovering the slope of 2/3. If you have 2 points and you can actually put those points on a Cartesian plane, on a graph, it's very easy. And the 2 is the rise over run, okay? And by rise we mean going up, and by run we mean moving forward, or the direction in which you would read from left to right. So, rise over run. Notice my line here. To get to this point, from this point to this point, I rise 2, 1, 2, and I run 3, 1, 2, 3, bing. Here to here, rise over run, 2 to 3. So let's go back to this equation. You know, I'm gonna let this. Now let's erase everything. Let's go back to this equation and graph this equation now on the Cartesian plane using the rise over run, using the slope-intercept method. So we're going to start with our b. Our y-intercept is negative 2. Let's go to negative 2 on the y-axis and plot that right here. Now let's do a slope of 1 over 2. And remember, that is rise over run. By rise we mean going up, run we're going left to right. So 1 over 2. So we start here at our point we made, and we do a rise of 1 and a run, 1, 2. And we can do that again. A rise of 1, a run of 2. A rise of 1, a run of 2. And then draw a line through those points, continuing. Okay, we've graphed this line. That's the proper graph for this equation of this line. this works both ways. We should become very quick at doing this. Let's find what the solution of this line is. Now let's label it line A. What is the graph of line A? Well, we're shooting for the y equals mx plus b. So let's fill in our b first. We see that this line crosses the y-axis here at 1. So, and it's positive 1, so we go plus 1. Now, what is the rise and run of this line? I see that we cross precisely over here at this point. We're not crossing precisely, but at this coordinate, we're again crossing precisely over the line, right through the corner of our, hitting our coordinate. So let's count rise over run. A rise of 1, 2. A rise of 2, and a run of, so we have 1, 2 for the rise, a run of 1, 2, 3. A run of 3. 2 over 3. So there's the formula for this line A. Y equals 2/3 x plus 1. We've gotten that slope. Now, let's talk about a few other things about slopes. Both of these lines we drew are going up. If you hit them, if you're flying, you hit them, you're going to go up. They have a positive slope. We could put a positive here if we wished. They've got a positive slope. This line, look at this other line. It's going down through here like this. Let's label it line C. I don't want to use B because we have B here. Let's label it line C. Line C has a negative slope. If we come flying along and hit it, we would go down. It has a negative slope. What we need to do, for a negative slope, either our rise is negative or the run is negative, whichever you prefer. So instead of going up, we could go down. And instead of running forward, we could run backward. Let's discover what the formula for this line is. First of all, we're looking for the b. Y equals something x plus b, if it's a plus. And it looks like it is a plus because we're crossing over up here in the positives. So we're crossing over up at positive 4 plus 4. We cross nicely through this point here at 4. Where's another point we cross nicely through? Here. Here. Okay, so let's go from this point down to this point. It's a drop, 1, 2, and a run of 1. So the opposite of a rise, 1, 2. And we move forward, 1. Except we're going to make it a negative because one of these needs to be negative. We drop down 2 as we move forward 1. 2 over 1, so we can actually change this. No sense in having a fraction. We can just go negative 2x plus 4. So our negative slope, we're coming down 2 as we go forward 1. It's a negative slope. These all had positive slopes. Finally, we need to talk about what about a horizontal line or a vertical line. So a horizontal line, this line is labeled line D. This line is cruising along right here. If you notice, this line is on negative 4 on the y, and when x is 0, we're negative 4. When x is negative 1, y is negative 4. X is negative 2, y is negative 4. Negative 4, negative 4, negative 4. Y is always negative 4. Therefore, the formula for that line is this. Y equals negative 4. There's no slope. The y-intercept, I guess, is understood here. Y equals negative 4. But that is the basic formula for the line. And we're going to have an x equals 1 yet to do. Let's look at this line, this vertical line that's going up through here. Let's label it line E. And it is on positive 5. So when x is positive 5, when y is 0, x is positive 5. When y is negative 1, x is positive 5. X is positive 5. X is positive 5, no matter what y is. So x equals 5, positive 5, no matter what y is. So those lines, x is always going to be a vertical line, and y is going to be a horizontal line. And they're straight lines is what I would say. There's no slope to them. They're straight up and down or straight horizontally. Okay, I think that covers it. It should give us the liberty to create any kind of formula we like. Let's do another one. Let's just make one up and arrange it in a strange way and do it from start to finish. We go 3x plus 5y equals 9. First step, change it to slope-intercept form. 5y equals negative 3x plus 9. Now, get the y by itself, divide by 5, divide by 5, and divide by 5. Okay, y equals negative 3/5 x plus 9 over 5. Okay, this is going to be a little difficult because our 9 over 5 doesn't quite, it's not going to cross smack through a dividing line, or 1 4/5. But we can do this if we really want to. Y equals, so we'll go over here to 1 4/5. Here's 1. We could say this is about 4/5, is about this point right here. And a rise, oh no, not a rise, a negative, a drop, negative rise, a drop of 3 over a run of 5. So from this point, we're going to go down 3. 1, 2, 3. And we're going to run forward 5. 1, 2, 3, 4, 5. There's our next point. 2 points is all you need to make a line, and we should be able to make a line that would go through there about like that. Okay, it has a bit of a curve in it. But we can plot any line now. As soon as you have the formula, you can instantly see. Start with a y-intercept, place on the y-intercept. Look at your slope, rise over run. If it's negative, change the rise to a drop instead. And not only can we go from any formula to a line, but we can go from any line to the formula. As soon as you look at the line, find the y-intercept, fill that in, and then discover what the slope is by checking what your rise over your run is, and fill that in. Okay, that's it for straight lines. I would like to talk a little bit about what you do if you have an x squared, but I'll put that in another video.